Let's run through a few more examples. Practice makes perfect. So this time we've got a fifth degree polynomial, so we should have 5 zeros and 5 factors by the time we're done with this. The list of possible rational zeros is quite short. The constant is a 3, so the only factors are 1 and 3. The leading coefficient is a 1. The only factor there is a positive or negative 1. So plus or minus 1 and plus or minus 3 are our possible rational zeros. Looking at our graphing calculator, it looks like we've got a 0 at positive 3 and at negative 1. But remember when we were talking about multiplicities earlier? This graph just touches at the negative 1 and then passes through the 3. So I suspect that that negative 1 actually has a multiplicity of 2. Could have a multiplicity of 4, but given the degree, I'm thinking probably multiplicity of 2. So let's give this a try. It doesn't matter which order we start with the synthetic division, using the 3 or the negative 1. If I can divide by the 3, I get a remainder of 0. Dividing by the negative 1, I get a remainder of 0. And when I try dividing by negative 1 a second time, I still get a remainder of 0. And by that point, I've got the fifth degree polynomial factored down to a quadratic, x squared plus 1. And I could solve with the quadratic formula, but pretty easy to solve by the square root method. And I end up with x equals plus or minus I. Remember, I is the square root of negative 1. So that means I've got 2 non-real zeros. So altogether, I've got my 5 zeros. The 3, the negative 1 with the multiplicity of 2, because that one counts twice, the positive I, and the negative I. And then my 5 linear factors, x subtract 3, x plus 1, and x plus 1, so x plus 1 squared, and then x subtract I and x plus I. So I've got my 5 factors. Here's another example. This one's a cubic, third degree polynomial. And looking at the graph, looks like I've got a 0 here probably at the 2, something between negative 2 and negative 3, and something between positive 2 and positive 3. Now the list of possible rational zeros, I forgot to write down, sorry about that. But there really wasn't anything there between the 2 and the 3. So one thing to remember about possible rational zeros, it only includes the rational zeros. So if they're irrational numbers are still real, so they still show up on the real number line, but they're not rational, so they don't show up in the list of possible rational zeros. Let's see what we can do, because the 2 looks pretty good. So using the synthetic division, I do get a remainder of 0. Leaves me with a quadratic, x squared subtract 7. Solving, I get x equals plus or minus the square root of 7, which is a real number, so it shows up on the real number line, so it's an x-intercept. Our non-real zeros don't show up on the x-axis. Okay, so we've got 3 of them then. X equals 2, the positive square root of 7, the negative square root of 7, and we've got our 3 factors. And if we were to FOIL this back together, this would match the original polynomial, the x cubed subtract 2x squared, etc. So speaking of that, here's one more topic. How to build your own polynomial. This is what I do when I write your tests. I sit down and decide, what do I want the zeros to be? So how about 3, 1/3, 2i, and negative 2i? I just made them up. So now I'm going to build a polynomial that has those 4 zeros. So it should be a 4th degree polynomial by the time I'm done. So with those zeros, I know I need these factors. X subtract 3, x subtract 1/3, x subtract 2i, and x plus 2i. And to clean up the fractions, I'm going to do is put in a coefficient of 3, because that's going to clean up my 1/3 and clear out the fractions. So we're going to start foiling, and it's easiest to take care of the non-real factors first. So the x subtract 2i and x plus 2i, I'm going to factor those together. Foil those together. X squared plus 2ix subtract 2ix subtract 4i squared. The 2ix and negative 2ix cancel each other out. And then I squared, remember, is equal to negative 1, so that negative 4i simplifies to plus 4. And I simply have x squared plus 4 here. And then next, I took the 3 and I just ran it through my x subtract 1/3, making it 3x subtract 1, cleaning up the fractions. And then I foiled the first 2 here, 3x squared, you know how to foil. And I get a quadratic here, times my other quadratic. And now I kind of do a super foil here. A 3x squared times x squared is 3x to the 4th. 3x squared times 4 is a 12x squared. Negative 10x times the x squared, negative 10x times the 4, etc. Clean it all up, and I've got a 4th degree polynomial, where here are the answers. So this is how I set about writing your test questions. I pick my zeros, I create the polynomial, and then I've got something for you to decode.